So let's go ahead and talk about the next part of this lab, part 3. That's the part that you guys have to do for this weekend. So this was just a review here. This is what you needed to do for part 2. You're probably not through part 2 right now. My guess is that you got the NaOH standardized. Hopefully you got that taken care of and you've got that set off to the side. We need to standardize your HCl probably on Monday, and then we'll see where we are after we get that done. Hopefully the titrations will run a little bit faster now that you kind of know what you're doing. Plus, it's easier to dilute the HCl than it is to measure out the KHP, so you don't have to worry about that step anymore. Yeah, like I said, we'll just see how far we get, and then play it by ear from there. I want you to go ahead and do this whole lab, though, because this is your first introduction to titration, and I need to make sure that you know how to do this right. So we'll take as long as it takes, I suppose. So after you have these two things standardized, now I should step back because I think the one thing that I didn't say on the last video was kind of explain what exactly the standardization process is, and that's, I guess, kind of important. When we start doing the Tums and the Rolaids, when we're testing those, we need to know exactly what concentration of NaOH and exactly what concentration of HCl we're actually dealing with. Okay? So it's not good enough to just use our graduated cylinders and our beakers and make measurements here and figure out, oh, it's about 0.1 molar and 0.15 molar for the HCl and the NaOH. We want to know to a higher degree of precision exactly what these concentrations are. Okay? And that's what the process you just did should hopefully enable you to do. Okay? All right, so that's that. Now we're moving on to actually doing the test that we were that's going to answer our beginning question here. All right? So, pre-lab problem 10, you've got a crushed antacid tablet sample having a mass of 0.208 grams, and you put that into a 250 milliliter Erlenmeyer flask. So then we're using our standardized HCl solution, and we're adding 25 milliliters into the flask. Now, I might change this part again. I think I changed this for some of you in part 2, where I said I will get you a graduated pipette where you can measure 25.00 or a volumetric pipette or something, so that we don't have to, or, just thought about this, I've got an extra buret in the middle. Maybe that could be the official buret to measure out your 25 milliliters of the HCl. I'll figure out something so that you guys don't have to keep rinsing out your burets because you're adding HCl and then you have to add NaOH and you have to add HCl. That's going to take too much time. So I want you to just keep NaOH in your buret, and then we'll figure out something else to measure out that HCl solution. Okay? So you're adding that 25.00 milliliters of HCl. Okay? Now the idea here is the antacid tablet is a base. All right, so you're going to add an acid to it to neutralize the antacid or the base. Okay. Once you've added that HCl into, and you've added plenty so that the antacid is completely neutralized, then you're going to do what's called a back. I'm telling you what you're going to do. This is just what happened for the pre-lab. This is, just a hypothetical situation here. Sorry, I'm not telling you what to do. That's not the point of this. Anyway, so you've got a titration, and, a random student is going to do what's called a back titration here. Now, the reason this student is going to do a back titration is because it's really hard to tell the endpoint when you're watching something change from pink to clear. It's a lot easier when you're watching it change from clear to pink, all right? You can just see it better. So, that's why what we want to do here is we basically go too far, right? So we have a base. The antacid tablet is a base, okay? And it's sitting at the bottom here. And you add a bunch of acid into that base. So much that you've completely neutralized the base, and now you have extra acid, okay? Now, after we add too much acid, then we can add in a certain amount of base and figure out how much extra of the acid that we had, okay? So that's kind of the idea with the back titration. Now what's the question here? How many moles of HCl were actually added to the solution? Okay. So the first thing we want to figure out here is just how many moles of HCl did we actually have, okay? Now, we have our standardized HCl solution, so we know the molarity of that. We also know exactly the volume that we added into the solution here, 25.00 milliliters. So we should be able to figure out how many moles of HCl. Yeah, I get it. It's a Friday. All right. So molarity equals moles over liters. Yeah, I know. Molarity equals moles over liters. So we know the molarity of our HCl because we standardized it before, and I'm going to have to look back and remember exactly what it was. 0.101 is, and that's, you know, using the hypothetical pre-lab questions here. So 0.101 is our concentration, is equal to moles over liters, and we added 25.00 milliliters, so that's changing that to liters, 0.02500 liters, okay? So then you just multiply those two together, and you can figure out exactly how many moles of HCl you added to the solution initially. 5. So that should be, the moles of HCl should equal 0.0025. Let's see, this is a little tricky. 25. I guess technically I think that should be just 2. Let's see if this PowerPoint agrees with me. 0.00252 moles. Oh, they rounded up. Yeah, see, you can round up or round down when you've got that 5 at the end. I thought with even numbers you were technically supposed to round down, not round up. But we'll go with the 0.00253 because that's what the PowerPoint has, so all the other numbers are going to be based off of that. Okay, so that's how you figure out how many moles of HCl you actually added into this when you added it to the antacid tablet. Okay? Now, here's kind of something that you might not be thinking about, but when this student did this lab, there's CO2 in the air that dissolves into that water, okay? And that makes it more acidic. Now, you saw this because I breathed into the titration the day that I showed you as a demo, and it turned it back clear, okay? And so we've got to get all the CO2 out. Now, the best way to do that, it asks what can be done to ensure all the CO2 is driven off. You may not necessarily know this. I think we talked about it a little bit in Honors Chem last year. If you heat something up, then it makes the gas leave the solution. Okay, so if you got gas dissolved in the solution, you heat up the solution, then it drives off all that CO2. All right, so actually I don't need to write anything down for this one. Heated to near the boiling point of water. That's going to make sure that all the CO2 is pretty much gone at that point. Okay, so then we don't have to worry about the acidity based on the CO2. Okay. After adding 3 drops of phenolphthalein to the solution, it took 3.52 milliliters of standard NaOH to back titrate to a pink endpoint. So then we have to figure out how many moles of NaOH did we add to the solution. Okay. So again, this is just the same basic calculation. Molarity equals moles over liters. Okay. The molarity of the NaOH, oh gosh, I don't remember. I think it was 0.153. On the average. I can't remember. I'm going to have to go back and look. Yep, 0.153. All right, so we know that this is 0.153 molar, and that's equal to moles. We're trying to figure out the number of moles divided by the liters. Okay, so we have to change the milliliters to liters here. 0.00352 liters. that's going to give us, so the moles of NaOH that we had to add, (5.39) times 10 to the negative fourth moles. So that's how many moles of NaOH we had to add in order to back titrate, to get it back to neutral, okay? Or, if you're not doing it in sig figs, did I give that same number? Back up. Yeah, 5.39, okay. Just want to make sure. Okay, so 0.000539 moles of NaOH. How many moles of standardized HCl were needed to neutralize the antacid sample? Okay, so this is a little tricky here, but if we look back at our last two answers, it took 0.00253 moles of HCl, or that's how many we added total, right? And then we can figure out, I need to write that number down, I'm going to forget it. 00253, sorry. And then we figured out that it took 0.000539 moles of the NaOH to back titrate it, okay? So, that's going to tell us how much extra of the HCl that we had that we didn't necessarily need, okay? So, all right, let me try to explain this well here. You add the HCl to the antacid, okay? The antacid is going to neutralize some of the HCl, okay? Or you could think of that the other way around. The HCl is actually neutralizing the antacid sample, okay? And then you have some HCl left over, all right? The HCl that's left over has to be neutralized with the NaOH, all right? So if we know that we started with 0.00253 moles of the HCl, that's how much we initially added into the antacid sample, okay? And we subtract the 0.000539 moles of the OH minus that we added. That's going to tell us, essentially, that's going to tell us how much of the HCl was needed in order to neutralize the antacid sample, okay? And I'm being lazy now. Rather than doing this, I'm just going to bring up the answer here, okay? So you take the 0.00253 minus the 0.000539, and it should give you 0.00199 moles of HCl, okay? So that is the amount of HCl that was needed to neutralize the antacid sample, okay? And then everything we added after that, all the HCl that we added after that was just extra HCl. And we figured out how much extra we had by back titrating, adding the NaOH back in and seeing how much it took to neutralize the solution, okay? Now, once we know the 0.00199 was the moles of HCl that were needed to neutralize the antacid sample, then we can figure out the mass of the HCl that was neutralized by the antacid in grams. Whoops. That's not what I meant. Sorry, I'm trying to look ahead here. Okay, they do the per gram thing. Okay, sorry. Well, you already just saw the answer, but I'll show you how to work this. So you've got the mass of the HCl. You want to know how much was neutralized by the antacid in grams. Well, it's not that hard to go from moles to mass, right? So we've got I forgot the number already. 0.00199 moles of HCl. Okay. So then we just figure out from moles of HCl to grams of HCl. And this is going to be 36.45 or so, rounding a little bit here. Okay, and that's going to give you your mass. So And actually, I'll just bring up the answer here. So you're going to get about 0.0726 grams. So that's the mass of the HCl that was neutralized by the antacid. Okay. So then, what mass of the acid was neutralized per gram of antacid? Okay. So mass of acid per gram of antacid. So we just take the mass that we got over here, 0.0726 grams of acid per gram of antacid. So we need to look back here and see how much of the antacid we actually had. And that's back in number 10. We had 0.208 grams of the antacid. Whoops. I thought I had didn't I have something written there? Oh, it's the next one. Sorry. So then divide that by 0.208 because that's the mass of the antacid. Okay. So then you're going to end up with the number that comes up here, 0.349. Okay. And that's just a ratio, so there's no unit that goes with that number. All right. So that's just showing basically how effective this antacid was at neutralizing the acid. Okay. So then you can imagine maybe a process in which we did this for two different antacid tablets, okay, and tried to figure out which one was more effective at neutralizing HCl. Okay. So then your assignment now is to write a procedure for determining the mass of the acid that gets neutralized per gram of antacid for both Tums and Rolaids, and then submit that to me. Okay, and it says do one trial for each antacid. Probably, honestly, it would be better if we did 2 trials of each, but we just don't have time. Okay, so as a time saver, just do 1 trial for each of the antacids. Okay, and you need to have a data sheet again. Tells you what to put on the data sheet, and that's basically it. Okay, so that's hopefully that gives you an idea of what you would want to write up for your procedure for part 3. Okay, so then on Monday when you come in, we'll make sure we do part 2, and then get as far in part 3 as we can, and then we'll kind of go from there. Okay, all right. Hopefully that helps. We'll see you on Monday.